Yes, hello everyone, welcome back to our channel students. So in this video we are going to talk about some key terms that we use in our daily life, and these key terms are also necessary for studying chemistry. Clear? So first one is mass and weight. Often we get confused between these two. What is mass and what is weight? And we sometimes feel that mass and weight both are same, but that is wrong. Mass and weight are completely two different concepts. So now let us understand that mass, it is the amount of a substance present in it. Clear? So mass of an object means how much of amount of a substance that is present in a particular matter, we call it as mass, whereas weight is the force which is exerted by the gravity of an object. Clear? In this case, in order to know the weight of an object, gravity plays a major role. For example, when you are landing on your earth, the weight will be different. But when you are going on an elevator, what you call lift, okay, the weight will be different, because there in elevator or in lift there will be some action of gravity, while in case of in land there will be some action of gravity. So in order to calculate weight, we need to take care of gravity and gravitational force, whereas in case of mass it is not required. It is the actual amount of a substance which is present in it. Yeah. So what is the SI unit of mass? The SI unit of mass is kilograms. Yeah. So kilogram, and we will mention it as kg. But generally in chemical laboratories we do not require that huge amount of substances, so we will use the chemical equipments in very small amounts. So we use grams for it. Grams. So in order to know the mass of a substance, we will use the analytical balance as an instrument. Analytical balance. You will be studying regarding this in your laboratory classes, practical classes. With the help of this analytical balance, we will measure the mass of a particular substance. So coming to the next one, volume. Volume means it is the space occupied by the matter. That means, I have said you yesterday while talking about the liquids. Generally volume is mentioned for liquids. Okay. So half liter of milk means it occupies some space. So that space which is occupied by the matter, we call it as volume. Generally the SI unit of volume is meter cube. Generally we will mention it by length whole cube. Length SI unit is meter, so it is meter cube. But there is a general assumption that in volume we will generally talk about liters. Okay, half liter of a milk, 1 liter of a milk. That is not an SI unit. The SI unit is m cube, because it is length cube. We will measure it by length cube. Length is, we will write it in terms of meter, so it is m cube for volume. There is a general assumption that volume is, we will talk in liters itself, half liter, 1 liter, 2 liters, but that is wrong. The SI unit is length cube, that is meter cube. Clear? So in chemistry laboratory we will measure the volume of any solution or any liquid by using pipette, burette, some graduated cylinders, and even we have the volumetric flask. Okay, these are the instruments that will measure the volume. And the next important thing is density. We often will get confused with this also, mass, weight and density. It is very clear that now regarding mass and volume. So density is the amount of mass per unit volume. At a particular volume, what is the mass? What is the mass of a particular matter? So that is density. So SI unit of density is SI unit of density is SI unit of mass by SI unit of volume. Yeah. So what is the SI unit of mass? is kg, and what is the extent of volume? It is m cube, meter cube. So kg per meter cube, it is the SI unit of density, but generally we will not use this meter amount, kg and meter. So we'll take gram per cm cube, gram and cm cube. Also you can even write it as meter inverse also. Both are right, no problem. Clear? So this is regarding mass, volume and density. So next very important thing is temperature. It's a known word for you, but what is temperature? What are the units we have to measure temperature? Temperature, it is the physical property. It is a physical property. Physical property of a matter or a substance of a matter to indicate hot or cold. Clear? It is the matter, a physical property of matter, not to indicate whether the matter is hot or cold. We will indicate it by temperature. Clear? So we have 3 units to measure. One is we will measure in degrees Celsius, that is Celsius scale. So we have units from 0 degrees Celsius to 100 degrees Celsius, that is the boiling point, melting point of water. Celsius scale. Second one is we have Kelvin scale, and third one we have it is indicated by K, and this is indicated by C. Clear? And last one, Fahrenheit scale, is indicated by degree F, stands from 32 degree Fahrenheit to 212 degree Fahrenheit. So in this, Kelvin is the SI unit. Kelvin is the SI unit which is represented by K. We have studied in our previous classes. So how can you convert from one scale to another scale? If you want to convert, if you have a temperature in Celsius scale, you need to convert it to Fahrenheit scale. It is very simple. We have a simple formula for this one. Now for conversion, degree Celsius to degree Fahrenheit. Now to get it, degree Fahrenheit is 9/5 degrees Celsius plus 32. This is the formula that we use to convert a temperature which is in degree Celsius form in order to convert into degree Fahrenheit. In our offline classes, we will be having some numericals based on this one, conversion of temperature from one unit to another unit. Clear? And the second one, how can we convert Celsius to Kelvin scale? It is very simple. Kelvin, you need to add in 273. Okay, 273. It is the value of Kelvin. So it is also in from the point of view of your examination, there will be some questions regarding this, converting from one unit to another unit, from degree Celsius to Fahrenheit, Fahrenheit to degree Celsius, or Kelvin to Celsius and Celsius to Kelvin. Clear? So this is regarding the temperature. So after knowing all these things, in chemistry we will be dealing with some huge numbers. For example, Avogadro number is 6.023 into 10 to the power of 23. 10 to the power of 23, that is a huge number, right? So in order to write all those huge numbers, we have a standard method of writing that we call it as scientific notation. Scientific notation is also known as exponential notation. It is the way of writing numbers which are too small or too big to write conveniently in. To write conveniently in standard decimal notations. Clear? So this scientific notation is also known as exponential notation. You have heard about this term, exponents and base, in your mathematics classes. Here also we use the same concept. So the format will be in n into 10 to the power of n format. Clear? So whereas this n is the digit term, and capital N is the digit term, and small n is the exponent that we use. Clear? So let's take some examples in order to write this. So let me take one number. It is 232.508. Clear? So this is a number. We need to write it in exponential notation. That is in the form of n into 10 to the power of n form, where n is the digit term and n is the capital N is the digit term and small n is the exponential term. So in this case, observe this. There is a decimal point after 3 digits. Yes or no? There is a decimal point after 1, 2, 3 digits. And after decimal point we have 3 digits. So you need to focus on this term. See, the standard way of writing the scientific notation is placing the decimal point is the decimal point should be placed after the first digit. Clear? After the first digit, the decimal point should be placed. So the decimal point should move from here to here. Clear? So that is the standard way of writing. So it means that the decimal point, which is after 3 digits, 232.508 is the value. The decimal point has to be moved one place and 2 places. Clear? It has to move one place and 2 places. So now 2.32508 into 10 to the power of how many points, how many places this decimal point have been moved. You need to write it this. Clear? So this is the simple way of representing number in scientific notation. It is that you need to first of all identify the decimal point where it is, and you need to move backward or forward so that the first non-zero digit term, the decimal point should be at after the first non-zero digit term. Clear? This is the first example. Let me take one more example now. Yes, we have this term. So how can we write? So that is the second example. No. This is only one. Yeah, take this one. So what happens now? The decimal point, this decimal point should be here, right? I said you that the decimal point should be after the first non-zero digit. Clear? Let me take simple one more example. The same way. The same example I have taken and I have just shifted back the decimal point for your understanding purpose. Now, where should be the decimal point? The decimal point should be here. Okay, this is the first non-zero digit. So the decimal point has to move forward 4 steps. Clear? So it is, the value is 1.6 into 10 to the power of, we are moving forward, so there should be a negative sign. When you are moving towards the right or when you are going toward the decimal point towards forward, so the exponent will get a negative sign. But whereas in this case, you are moving the decimal point toward backwards or towards left. So the exponent will get a positive sign. So in this case, the decimal point is there. You need to move to this 1.6. So we are getting a negative sign in this case. Clear, students? So this is how we write the number in the scientific notation. So now, how can we add two numbers with decimal points? How can we add? Let's take an example. So, addition. 6.65 into 10 to the power 4 plus 8.65, right? 8.95. You can take anything into 10 to the power of 3. So now how can you add this? It is, you need to focus on the exponential. Only for addition and subtraction, you need to focus on the exponents. Yeah? So both should be same. So either you have to convert 10 to the power of 4 to 10 to the power of 3, or you have to convert this 10 to the power of 3 to 10 to the power of 4. So whichever is possible, whichever is easy for you, you can do that one. So better let us convert 10 to the power of 3 to 10 to the power of 4 itself. So we need to increase 10 to the power of 3 to 10 to the power of 4. How can we increase the exponents? So we can increase the exponents by passing the decimal point towards left side. Yeah. So when the decimal point is moved backward or the decimal point is moved towards left, we can then increase the exponents. Clear? So let's take the same example. 6.6 into the power 4 plus we are moving this decimal point here. So it is 0.895 into the power 4. So now you can add this term as this 10 to the power of 10 to the power 4 is same. So we can add 6.65 plus 0.895 into 10 to the power of 4. So what is the value? So it is 7.545. You can do some more examples in your home. Okay, this is regarding addition. Let's talk about subtraction. Subtraction also is the same thing. We need to keep the exponents same. Let's take an example. 2.5 into 10 to the power of minus 2 minus half. It is 4.8 into 10 to the power of minus 3. So now these two are different. These two are not same. So now what we have to do? We need to convert this 10 to the power of minus 2 to minus 3 or this 10 to the power of minus 3 to minus 2. So whichever is easy for you, whichever is applicable, we can do that. So now let us convert this minus 3 to minus 2. It means that we are not decreasing here. Minus 3 to minus 2 minus 1, then 0 plus 1 plus 2 plus. Clear? So it means we are increasing it. So we are increasing it. So if we are increasing it, then what should be the position of the decimal point? It should move towards the left side. Clear? So it is 2.5 minus 2 minus of, we need to increase by one value. So it is 0.48 2.5 minus 0.48 into 10 to the power of minus 2. What's the value for this? So it is 2.02. 2.02 into 10 to the power of minus 2. Dear students, this is how you add and subtract the numbers with the scientific notation. So now let's go for multiplication. So in case of multiplication, there is no rule that exponents should be same. There is no rule. So in this case, you need to just multiply the digit term and you need to add the exponents. That is. So let me take an example for this one, multiplication. 5.6 into 10 to the power of 5. This one value into 6.9 into 10 to the power of 8. So in this case, you need not to make the exponents same. No need to worry in case of multiplication and division. So directly what you need to do is you need to multiply these two digit terms and you need to add the exponents of this to 5 plus 8. So let me write it now. 5.6 into 6.9 into 10 to the power of 5 plus 8. Clear? So this is the simple way. So what is the value? 5.6 into 6.9. It is 38.64. 38.64 into 10 to the power of 8 plus 5. It is 38. So be very careful that in case of multiplication you need not to take the risk. There is no need to maintain the same exponents. You can directly multiply the digit term and you need to add the exponential term. So the last one, it is division. It is division. Here also the same thing, you need not to worry about the exponents. Just divide the digit term and subtract the exponents. And there in case of multiplication we are adding the exponents. So in this case you are just subtracting the exponents. Let us take an example for this. 9.8, 2.7 into 10 to the power of minus 3. 2.7 into 10 to the power of minus 3 by 5.5 into 10 to the power of 4. Yeah. So now you just have to divide these two now. 2.7 by 5.5 and you need to subtract these two, minus 3 and minus 4. So let me write it. So it is 2.7 by 5.5 into 10 to the power of minus 3. It will be minus 3 and minus 4. So what is the value? 2.7 and 5.5 is 0.4909 into 10 to the power of minus 3 and minus 4. It is minus 7. Clear? So this is how you divide the numbers with scientific notation. So we are ending up here. Thank you, students.